Okay, so we need to simplify the following expressions by using double angle identities. So the first one, 1 plus cosine of 2x over sine 2x. So we have to substitute something for the top and the bottom. So let's do the denominator first, because that one, we only have one choice. If you notice in our table, the only thing that we have for sine of 2x is 2 times sine of x cosine of x. Okay, now for the top, we actually have several choices because cosine of 2u can be equal to these three things. So we need to decide what will work best. Now, if you plug in the first one, the cosine squared minus sine squared, it will not help us at all because we will have two trig functions that are subtracting each other, and it will not simplify anything. Now, the last one looks almost like a choice, but if you notice when you plug that in, you will have the one from here plus the one from the other one, and we're going to have a subtraction on top, and things won't cancel nicely. But let's take a look what happens if we plug in the middle one. Plus 2 times cosine squared of u, or rather not u, x, minus 1. Okay, now we have a plus 1 and a minus 1. These two things cancel out. So we're going to get 2 cosine squared x over 2 sine x cosine x. Okay, so this puts us in a nice place because now the 2's cancel out, and also the cosine from the bottom cancels one of those on the top. So what we have left is just cosine x over sine x, and you should recognize this one as just being equal to cotangent of x. Okay, let's take a look at the next expression. So we have sine of 2a over sine squared of a. Okay, so this is not too difficult. So sine of 2a over sine squared of a equals, now for the top, we only have one choice what we can substitute in. So we have 2 sine of a cosine of a over sine squared of a. Okay, so now we just cancel the sine on top with one of the ones on the bottom. So now we have 2 times cosine of a over sine of a, and again we get to cotangent of a. So let's take a look at the last one. 2 sine squared of theta plus cosine 2 theta. Now we're going to substitute something in for the cosine 2 theta. Again, we have 3 choices up above, but one of them kind of sticks out because we can't change the sine squared, but we have one choice up above for the cosine of 2u that only has a sine squared and no other trig function. Okay, so which is the last choice? So we can see this guy. If we plug this in for cosine of 2 theta, we get 2 sine squared theta, and then we're going to get plus 1 minus 2 sine squared theta. Okay, now you can see that this guy right here and this one is the same, so they cancel each other out. So our answer boils down to something really simple, which is just equal 1.